Hello, friends. I'm Ram Lakshmanan. So I'm the architect of GCEC Fast Thread ePro. I would like to welcome all of you to this month's webinar, Spotting the Trouble Early, What Java GC Patterns Can Tell You. Friends, there are patterns everywhere. All throughout the world, there are patterns in every place, right? So, but GC patterns, if we see, we all look at the garbage collection behavior. We all look at the garbage collection graphs. But there are certain patterns which I've identified over years. It took several years for me to identify these patterns. So these patterns can tell you what's going on in your application, and it can also tell what's going to happen in your application as well. So I'm going to be sharing these patterns, what I learned over these years in this session. Okay. So let's get started, and feel free to ask, put your questions in the chat, the Q&A. So I will answer them towards the end of the session. Okay. Okay, let's get started. The first pattern that what we are going to discuss is an healthy sawtooth pattern, right? So this is how that pattern will look like. See, friends, look at this. This is a garbage collection behavior pattern. Look what's going on. See, the request is coming, the memory is building up. When this full garbage collection event ran, the memory dropped all the way to the bottom. Okay. So now once again, request is coming, the memory is building up, keeps on building up, and this full garbage collection event ran, the memory dropped all the way to the bottom. You see this beautiful sawtooth pattern, a perfect sawtooth pattern going up and down, up and down, up and down, right? So this, if you see this kind of a pattern in your application, it means it is a very healthy application. There is no problem. There is no memory leak in this application. There is no memory contention in this application. Why do I say there is no problem in this application? Friends, look at this. Look at the bottom points, right? It goes up, and when it comes down, it drops here. It's dropping at kind of the 2 GB. Now, when the next event ran, once again, it is dropping at a 2 GB. So if I try to put a slope connecting all the bottom points, look at this. This slope is going at kind of a 0 degrees. Look at this black arrow, which is connecting all the bottom points. This slope is going at a 0 degrees. If it goes at a 0 degrees, that means it's indicating there's no memory leak in this application. I'm going to be showing you some patterns where the applications are suffering from memory leak, and how does the graph is going to look at it? How is the slope going to look at it? You look at it a little later. But this indicates there is absolutely no problem with this application. There's no memory leak. This application can run for several days, weeks, months without restart, right? Okay. So how do we gather this kind of a pattern? How can I see the pattern? How can I source this pattern for my application? So friends, for that, the best way to study your garbage collection behavior pattern is by your garbage collection logs, is by enabling the garbage collection log. You can enable the garbage collection log on your application by passing these arguments. So if you're running in Java 8 or before version, pass this argument and here specify a file path. When you specify a file path, the JVM will start to write the GC information, the GC event information into this file path, whatever you're given. And if you're running on Java 9 and above version, so use this argument and give this file path. When you give this file path, the JVM will start to log the JVM events information into the file path what you have specified. And friends, enabling a GC log on your production servers adds almost zero overhead. See, you can go to blog.gcec.io. There we have published white papers showing the overhead that enabling the GC log adds to your application. It is almost zero. You cannot even measure. It is very negligible. Even if it runs for a few days, it's just going to be a very, very, very limited file. It's not a very big file that it generates. So it does not add any noticeable overhead. So keeping it turned on all your production JVMs gives you significant benefits, right? Okay. So now you have enabled the GC log. This GC log is going to contain the raw GC information, GC events information. From this GC log, how am I going to see this GC pattern, right? For that, you can consider using this kind of a GC-EC kind of a tool. So this tool can analyze your GC log, and then it can generate patterns. It can give you the graphical visualizations of what's going on in your memory. So here is an GC log file that I have, which I collected earlier before this session. So you can go to this tool GC-EC. You can go to the tool GC-EC online, and you can upload your GC log file, or there is also an on-prem installation of this tool is also available for you. So you can download and install the tool on a local laptop and do the analysis in case if you're working for some financial institutions or any major institution where you don't want to upload the data. You can download this tool and install it locally as well. So, okay, so now let me upload this GC log file, which is generated by enabling that GC log statement, which is enabled. So once I upload, instantly the GC-EC tool is going to analyze, and then it's going to report what's going on in your application memory, in your JVM memory. It also gives you kind of recommendations or pass this argument. It will improve your performance, reduce this. It gives you those kind of recommendations to enhance your JVM performance. But let's focus on the topic that what we have in our hand. It is the GC behavior pattern. See here, you can see this is that this is a GC behavior. This is a memory behavior. You can see the request is coming, building up, and it's going down. You see this beautiful sawtooth pattern, and it's going at 0 degrees. This means there is no problem in this application. It can keep running for a while, okay, or forever. Now what we will do, let's come back here. Let's look at the second pattern. The second pattern is called as a heavy caching pattern. What does this heavy caching pattern means? Look at this. So this is that example of this pattern. Look what's going on. This is pretty close to somewhat similar to the pattern that what we saw earlier. You can see the request is coming, the memory is building up, and then it dropped. You can see the sawtooth happening, right? You can see the sawtooth pattern happening. But one difference in between the previous pattern, what we saw and what we are observing now is when this GC is ran, it is not going all the way to the bottom, right? This bottom points are not coming here, right? Let's go back here. If you see this one, what we looked at earlier, it is dropping all the way to the bottom, right? You're seeing it's dropping all the way to the bottom. Whereas look at this guy. It is not dropping at all, right? It is kind of stagnating. It's not able to go below the 40 GB. Right? It's going all the way till 60 GB. After that, it is dropping to 40 GB, but it's not able to penetrate, go further below 40 GB. Why is this? What does this pattern tells to us? Why does the garbage collector is not able to reclaim the memory more than, it's not able to go below this 40 GB? What is the reason? Friends, the answer to this question is, if you see this kind of a pattern where it's not able to go all the way bottom, it means this application is caching data. These are the long-lived object which is there in your memory. These are all having active references. Most likely, they are the cache which is there. So you can see, looking at this, we can say this application is having a kind of a 40 GB of cache. A lot of data is being cached in this application. If someone asks you, how much data is your application caching? Say if you're caching a lot of data, if someone is going to ask you how much GB or how much MB of data your application is caching, the garbage collection graph analysis will tell you, okay, here I'm not able to go beneath it. It means more or less this application is caching 40 GB of data. And this will be very surprising to a lot of developers, right? Even we don't know how much cache our application is caching. Looking at this, we will know. Or sometimes it will be revealing because we might have thought, oh, we are only caching 5 GB or 10 GB of data. But why here the GC behavior is showing it as if we're caching 40 GB of data? Maybe are we duplicating the contents? Are we using a wrong data structures? It can simulate can stimulate those kind of conversations and thought processes. Okay. So let's move on to the third pattern, which is called as a consecutive full GC pattern. What is this consecutive full GC pattern? Look at this, my friends. See here, look what's going on. Here you can see the request is coming. It is just progressing. But here you see this red triangle. Those are all the full garbage collection events. They're kind of repeatedly running. And then it is kind of repetitively running here. You can see it is running. See, right now it is running for October 6th, 11 a.m. It started, if you're seeing the live one, let's look at this in the live graph. Let's look at this in the live graph. If any such problems are found, the tool will automatically, GCC tool will recognize those patterns and then report it to you. Oh, the consecutive full GCs are happening. Here are all the steps to resolve them. So we give you recommendations, pointed recommendations on how to resolve them. So now let's come here. Friends, look at this. Right here at 12:02 p.m., a full GC event ran. Immediately, 1 minute later, another full GC event is running. See, you can see, let me just zoom it in here. Okay, look at this. This is very clear. From 12:02 to repeatedly till 12:36, for 36 minutes, the GC events are running. But the memory didn't go down. For 36 minutes, the memory didn't go down. See, friends, let me tell you, even if you see one red triangle means a full garbage collection event. Full garbage collection event runs on your entire JVM trying to reclaim all the unreferenced object. Even when one red triangle appears, your CPU is going to go up. CPU is going to go up to 99%, 90, very high percentage is going to go. And then it will drop. Whereas here, it is repetitively running. It means all the way from 12:02 to 12:36, your CPU will be at 100%. And also another thing to notice, when a full garbage collection event runs, your application stops. It will not process any customer transactions. And if there's any health check that comes during this time, it won't respond to those. So why is this happening? Why is this happening? What does it mean? After 12:36, it recovered. The full GCs are not running. It dropped and it started to go through fine. What's going on here? What could be the reason? Friends, this pattern means we are called as a consecutive full GC pattern. It means the full GCs are running consecutively again and again and again. Friends, this kind of a pattern happens when? When does it happen? And what does it mean to you? If this pattern happens, it is indicating, it means there is a high traffic volume that is coming to your application. During this window from 12:02 to 12:36, there was a surge in the traffic volume. Your application was bombarded with a lot of requests. Since a lot of requests are coming, your application is creating a lot of objects. Since a lot of objects are created, your application, your JVM is struggling to handle because there's not sufficient memory is allocated to handle such an incoming flood of requests. So when this kind of thing happens, then you want to investigate what should you do? Because when this happens, your application will become unresponsive, right? Because when full GCs run, it stops. And here it is repeatedly running, so your application will become unresponsive. So health checks will start to fail, and CPU will be at a high spike. But after 12:36, it recovers and will start to run. See, when this happens, you want to check whether there's any surge in the traffic volume. And sometimes, see, I used to work for before I started doing this JVM tools building, I used to work for a financial institution, a very large financial institution, right? That financial institution, I think people in North America, there's a Girl Scouts. There's a Girl Scouts who sell cookies, right? So when those kind of a Girl Scout leader comes in, when he tries to log in to that the financial institution's online bank, when they log in, that leader would have like 300, 400 accounts with him. Because for every scout is going to have one account. So he's going to have 300, 400 accounts. So when that kind of a customer comes, now this platform has to make 300, 400 backend calls to the backend system of record, get all those account details, massage it, and then present that information. So that consumes a lot of memory. So when those kind of customers comes, then your application will start to generate a lot of objects. It needs more memory than the typical memory that is allocated. Similarly, sometimes there could be you may run a batch job. Maybe what if a batch job is running? When a batch job is running, continuously your application is going to be bombarded with requests. At the time, do you have enough requests? At the time, do you have enough memory, right? So when there's a surge in the traffic volume, you see this full GC is running repeatedly. But once the traffic goes away, once the traffic dies down, right, then an application recovers. See, that's why it is able to recover. But you're going to see the patterns a little later where your application will not even be able to recover, right? So when this kind of a thing happens, what are the solutions for me? How do I go about fixing it? Right? So these are all the causes for this pattern, right? When there's a consecutive full GCs, there is a spike in the traffic volume. Maybe it's a batch traffic running, or whether there is the example I told, like the Girl Scout kind of account request is coming, or maybe it is during a peak traffic volume time period. Say some applications, say you're a financial institution, you may see morning 8 a.m. to 9 a.m. or 10 a.m. is where your peak traffic volume is period. So maybe at that time, there is more requests are coming. That means more objects are creating. That means garbage collection is running very heavily. So your application can go unresponsive. So these are all the reasons which can trigger this full garbage collection event. When this happens, what are the solutions for us? The solutions are increase your heap size. That is XMX, because when consecutive full GC pattern happens, it means there is a shortage of memory. Your application is hunger for more memory. Allocate XMX, right? But the second one is add more JVM instances. Say, suppose you don't want to allocate more. If you're going to increase the heap size, that means it has its own consequence as well, right? Because now you have to GC tune it, whether you want to see whether there's enough capacity on your server where you're running, right? So other thing is what you can do is you can increase your number of JVM instances. Say, suppose you're running, I don't know, 10 JVMs or 20 JVMs. Try running 25 JVMs. So that when you add more JVM, that means virtually what you're saying is you're allocating more memory, more capacity to the request to process. You can do this as auto scaling as well. Maybe from 8 a.m. to 9 a.m. is when that traffic surge is there. Or when your batch job runs only at the midnight. Only during that time, you can auto scale the number of your JVM instances and then scale it down, right? You can do that. So these are some of the strategies to address this kind of a consecutive full GCs. And you don't have to worry about these things, because whenever we identify this, we report it here. And here we give you the recommendations. You can click on it and see what needs to be done specific to your application. Now, the fourth pattern that what I want to discuss is called as an acute memory leak pattern. So what is acute memory leak pattern? And look at this garbage collection behavior pattern. Look what's going on. Look, you can see the request is coming, the memory is building up. And now when this full garbage collection event ran, the memory dropped here. See, initially it dropped to kind of a 22 gig. Now requests are coming, the memory is building up. When this full garbage collection event ran, the memory dropped to kind of 26 GB. As time is progressing, you can see the memory is starting to, where it drops is not right now. Let's see, when this event ran, the memory is at kind of a 31 gig. Initially, look at this where it is at a 22 gig. If I try to put a slope connecting all the bottom points, look at this black dotted arrow. This black dotted arrow is going at a kind of a 10 degrees. You can say this is going at a kind of a 10 degrees. But friends, look at this. What was happening in the initial one, in this LT pattern? This is the very first pattern we discussed. So this is going at a kind of a 0 degrees. See, this is going at a 0 degrees. Whereas now, this acute memory leak pattern is going at kind of a 10 degrees. So when you see this kind of a pattern happens, but don't worry, the tool, the GCC tool recognizes all these patterns and gives the remedies for you. When you see this kind of a pattern happen, it means it is telling this application is suffering from an acute means a slow memory leak. That is, it's not aggressive enough. It's not going to crash immediately, but there is somewhere your developer did not deallocate or remove the objects, unnecessary objects. So it is starting to build up slowly. And if this application continues to run, you are going to see a serious consequences, which we'll discuss as a next pattern. But this is indicating this application is going towards, it's marching towards a crash, right? It is going towards a crash. If it's going to run for a few hours, or few days, based on the number of requests that is coming in, it's going to crash. So friends, so we want to catch our problems, our performance problems right here, not when it manifests as a serious out of memory error, then reacting to that is very late. If we can catch during this time, so this time, the customer is not seeing any impact, right? Your application is still responding, but slowly a memory leak is building up. So if you can catch at this stage, this is a beautiful stage to catch to prevent outages. This is a real forecasting. Wonderful thing, right? Without causing any outage to your customer, we can detect, oh, the problem is going on. Now we can do some corrective actions. Can maybe recycle the JVM, right? So that the user does not get impacted into those sort of things. Okay, how am I going to do this? I'm not going to be sitting in front of my machine, and then I don't want to be looking at it, taking the log every time and uploading into a tool, and then looking. It's not possible. And of course, if you're deployed across hundreds or thousands of JVM, it's totally impossible to do it for every JVM. Friend, that's where there is a GC analysis REST API is available. So this is a very simple to use REST API. Let's look at this. So you can trigger this. You can trigger this API just like this. You can just do a curl command and give the location of your GC log file. It can be from a production servers, and then you just trigger it, the API endpoint with your key. That's all. When you do that, see, this API is available. You can get it on-prem and installed, or also it's also available on the cloud, right? When you do that, all the metrics that what you are seeing in this visual report, all these metrics, the throughput, CPU, and all these things are now available for you in the JSON response. It's available for you here. And here there is this flag called as problem. It's an array element. And if we detect any problematic symptoms that is going on in your GC, we will flag it as an error for you. Right? So if you see this problem to be coming up, then you may want to take some corrective action rather than so that you can catch the problems advanced rather than reacting to it. Right? And also, my friends, I would strongly recommend you can recommend using this API in your CI/CD pipeline, because look what's happening, so that we can catch all these memory leaks or these memory problems early in the game. It's a true shift left rather than reacting to these problems in production. What if I can catch it during the testing time itself? What if during the development cycle itself I want to catch? Friends, there is one very beautiful metric I want to share with you here. It's called as an average creation rate. Look at this. It is telling me this application is creating 30 megabytes per second. It gives amount of objects created in a unit of time. It's telling it's creating like a 30 megabytes per second. So what if in your previous release or previous code commit, it was only creating 15 megabytes per second? Maybe your developer has committed some inefficient code, and now you are creating more objects. Then it became 30 megabytes per second. So what do you do? As part of your CI/CD pipeline, maybe on a nightly basis, once you do the build, run a performance test or running for like a 10-20 minutes, and then trigger this API. So once you trigger this API is going to give you back what is those object creation rate. And here we in this link is given for you here. We are talking about what are all the metrics you want to monitor in the response, the JSON response that is coming back. It has this problems, which tells whether any problems are present. What is your average pause time, max pause time, throughput, object creation rate? You look for these metrics. And if these metrics breaches the value, then fail the build. Fail it right there. This is a very beautiful thing to be done to catch a lot of performance problems very early in the game. In fact, this API response even gives you the graph images, so that in your CI/CD report, you can embed your graphs, your memory graphs. You can embed it. And then you can tag it, it can do all those wonderful things, right? I'm not going to go much into the details, but this is something you can consider using. That is using this REST API in production to catch the performance problem early, and also in a CI/CD pipeline, right? So something for you to consider as a takeaway. Okay, so now let's move on. Friend, this is a very interesting pattern, memory leak pattern. What is this? The GC1, the GC1 ran, the memory dropped here, and then memory dropped here. So initially it dropped to 4 gig, and then now it became 4.5, like this. So after a point, look, it's keep on going up, and after a point, it's not at all dropping. The memory is not at all dropping. It is the full GC events are keep on running repeatedly, or kept on running repeatedly. Friends, I told earlier, even if you notice one red triangle, that red triangle is going to consume a heavy CPU spike, and also it's going to stop your application. And here it's repeatedly running and it's not recovering as well. It just keeps on running like this. It means it's a classic indication this application is suffering from a memory leak. That's what it means. Boom. So when you see this kind of a pattern, it means it's a confirmed you're having a memory leak. So if you take this kind of a GC log and upload it, right? The tool at the top itself detects these things. Oh, here is this memory leak. Here are the steps to resolve the memory leak. We give you guidance. And here are some parameters that you can pass to enhance the JVM performance. Right? It is keep on running. And one thing to note here, look at this, my friends. Look at the reclaimed bytes. This shows how much bytes are getting reclaimed. See, initially, the full G7 are able to reclaim a lot of memory, like it was able to 4.5 gig. But towards the end, it's not able to reclaim anything. It means the memory is fully clogged up. It's not able to recover anything. It means a classic memory leak. Your application is suffering from out of memory error. When this happens, how we are going to diagnose the problem, right? That's what we'll discuss now. And friends, first of all, your JVM memory, right? We just say it as a JVM memory, one single thing, but your JVM memory internally has multiple regions. Like there is this heap memory, and then there is native memory, and native memory has all these regions. So I have given, you can go to our YouTube, so where I have given a talk on 9 different types of out of memory error. So because of interest of time, you wouldn't be able to go in detail in this session, but you can check it out in our YouTube, right? When you see this kind of a pattern happening, it means what does it indicate is your heap memory is getting saturated. Your heap memory is getting filled up. So when your heap memory gets filled up and there's no more room to create new objects, you are going to be your JVM is going to throw out of memory error Java heap space. So this is the out of memory error you are going to get. When you get this out of memory error, how do you debug this problem? How do you diagnose this problem? Friends, for this, I have put together a very simple example to simulate an out of memory error for our discussion. I put together a simple program which is going to simulate out of memory error, just to showcase you what triggers out of memory error. Look at this. Here there is this memory leak demo. It has an object 1. Right? Here there is a start method. It is invoking the grow operation, on this object 1. So I'm clicking on this. And this grow operation, look what it is doing. It is saying insert the records into this map manager. So let's go here. What does this insert record does? Look, what does that insert record does? It is saying it is going on an infinite while loop. Infinite while loop, it never terminates. While true, it means it never terminates. And now here it says, look at what it's doing. It's saying my map.put key 0 and then large string 0. You see this my map is nothing but an hash map. So to that it's adding a key 0 and then large string 0. And now it just for every 1,000 iterations it's printing, it's inserted 1,000 records. And now when it comes back again, then it's going to insert key 1, large string 1, then key 2, large string 2. So that means your hash map is going to build, it's going to be heavily populated. It's going to keep on, this application is going to keep on inserting the records into that map until your heap memory gets saturated, right? So let me run this program. Okay, so I'm running this program. So you can see It is saying inserting the records. Okay. After a point, it confronted out of memory error Java heap space. So this is how a typically out of memory error happen. Of course, no developer is going to say while true like this. No one will do it. But something of this nature will happen where the leak will start to happen. So here I've explicitly said true, and then I keep on adding. But developers wouldn't intentionally do it, but accidentally they may do it. And then now your map is going to get filled up, your data structure is going to filled up, and then you're going to confront this error. When you can confront this out of memory error, how do you debug this problem, right? Friends, the best way, right, to debug out of memory error heap spaces, you want to capture heap dump, or not best way, it's the only way. You need to capture a heap dump from your application, from your JVM. So what is an heap dump? Heap dump is nothing but a snapshot or a photograph of your objects in memory. So it's going to take a photograph of all the objects in memory, and then it's going to write it to the disk. It's going to be a very huge file. It's a binary file. So how do you take heap dump? Friends, here there are 8 options for you that you can go to this blog and see. There are 8 different options to take heap dump. But my favorite option is using this open source script. So we do have this open source script called as a YC data script. It's an open source script. It's available in GitHub. Anyone can use it. See, whenever there is a production problem, see here I'm explicitly telling you it's an out of memory error. So now you know you need to keep them. But what we always hear in production is, oh, your application is unresponsive. Oh, the CPU is spiked up. That's all we hear. But we don't know the details. So the best way to diagnose any production performance problem is to equip yourself with 360-degree data. So this script, which you can trigger like this, YC minus P and process ID. This is available in Linux, Windows, and all flavors of Linux and Mac as well. So when you trigger it, you can trigger it like minus P and process ID, give your JVM process ID. When you trigger, it's going to capture this 360-degree data. GC thread heap, and also your container level, host level, network level information, and also your application logs. See here, it captures and auto discovers where all your application writes into. It picks up those application logs and kernel logs. It gets everything and bundle them up and gives you a zip file. It comes very handy for you to troubleshoot any sort of production problems. Okay. Once we have this script, this has bundled and given you the dumps. Now what you want to do, you want to use like a heap dump analysis tools like heap hero. Heap hero is one of the tool. You can use this tool to analyze the heap dump. So what you can do, you can take that heap dump file from the script, and then you can upload it to the tool. See, there is this heap hero is available here as an online cloud edition. And also it's also available as an on-prem. Friends, I highly recommend not to use cloud, but rather use on-prem, because here's the reason. The cloud, the heap dump is a confidential data, because what is a heap dump? Heap dump is a snapshot of your memory. What is there in your memory? Your application is processing social security numbers, credit card numbers, VAT numbers, processing all this sensitive information. So it is highly confidential data. So you don't want your confidential data to be uploaded on the internet and then processed on some external servers. Rather, you have this on-prem, install the tool locally on your machine, and then do the analysis. So once you install the tool, and then you can upload the tool is just going to look like this on your on-prem. You can just upload your heap dump file. And there are also a REST API is also available, which can automate the heap dump analysis. But now let's look at one of the samples. I uploaded this report and I got it ready. Let me show you it. This is how the report will look once you upload. The report is going to look like this. Okay, see here it says, so if it had detected any problems, our tool has intelligence to detect any memory leak is going on. Here it says, oh, this instance, this hash map is occupying 99.92% of the memory. To see the details, click here. Right? So it gives you all these information. So now, see friends, whenever there is a memory leak, come to this largest object section and look at it, because whenever there's a memory leak, probably a top 2 or 3 objects are the reasons for the memory leak, because always the leaking object tends to grow in size. So they tend to become the largest object. So look at it here. So this is this hash map. is the largest object because see, look at this, occupying 99.92% of memory. So this is the culprit, which is growing in size. Now I know this is the culprit, but I want to know what are the contents of this object. What is present in this hash map that is causing it to be so big in size? To do that, click on this more. And now say list of outgoing references. What is outgoing reference? But that means references going outside from this hash map. That means what are all my children? What are the references going outside from me? That is this outgoing reference. Let me click on that. And I click on that. Okay, here is this hash map. You can see all the hash map internally as a table. Right? I clicked on this table. So it seems like it's a very large table. Right? Okay, now it has loaded. You see this table is having like a 1.69 million entries here. It's having like a 1.7 million records are present in this table. I'm able to see this. And what is the value that is present in any record? I just click on here. When I click here, friends, look on the right side. You can actually see the real data, the raw data. Here you can see this is the key, the large string that we added is showing up here. So let me click on some other thing. You can see this number is changing, right? This is what it is. So now I understand what are the children of this object, which is accumulating, okay? This is a very good information. But now the next thing is, I want to know who is keeping this hash map active in memory. Because so that I will know, I can know and fix which part of the code I need to fix, I'll get to know. To do that, click on the same more and then say incoming references. What is incoming references? Incoming reference means all the pointers to this object, who is pointing to this object, so that I will know who is keeping them active. So let me click on this incoming reference. Okay, so you see this hash map is referenced by this map manager. Look at this, friends. This hash map, right, is referenced by this map manager. See, it's pointing out. And this map, it even tells you the variable. You see this variable name is pointed as my map. Look at the variable we have used, my map, right? And then, so now if I keep drilling, so I can see the hierarchy. This map manager referenced by object 1. And this object 1 is referenced by this memory leak. I can walk through this hierarchy so that I will get to know who is the real guy who is holding on to the reference. Okay. With this information, you can arrest these sort of out of memory errors. Okay. So let's do a quick recap of this out of memory error, Java heap space. So this happens when there is a memory leak due to a buggy code, just like what I showed. And sometimes, my friend, this out of memory can also happen if there's a rise in the traffic volume also. When there is an increase in the traffic volume, then also it can happen. So what are the solutions to fix this problem? To fix this problem, fix the memory leak in the code. If it is happening because of the spike in the traffic volume, then increase the heap size. What are the artifacts you need to troubleshoot this problem? You need garbage collection log and heap dump. What are the tools you need? You need to analyze GC log, you need GCEC, and then to analyze heap dump, you can use heap-hero. Okay. Friends, now with this, I'm coming to the last pattern. That's what I want to discuss. It's called the metaspace memory leak pattern. Let's look at this one. Look at this graph, this behavioral graph. Look what's happening. The memory is going up and then it's dropping, but after a point, you can see the full GC events are running here at the bottom, when it's at the bottom. Friends, this is a little bit peculiar, isn't it? Because the garbage collection events should run when your memory is at a ceiling limit, right? When you're going to the top, if that where the GC should run to recover the memory. But why it is running at the bottom? If you see your earlier pattern, look at this. In this earlier pattern, the full GCs were running when it's at the top. Which makes sense because my memory has reached the ceiling limit. Now the garbage collection is trying to recline, so it is running. Whereas here, this is very peculiar. Why it is running at the bottom? What is the reason? What is the reason for this? Right? This is very interesting, right? Friend, the reason for this is, When this kind of a pattern happens, it means there is a memory leak in the metaspace region. To this, we need to understand the JVM regions a little bit more. Look at this, my friends. I told that JVM has multiple regions. There is a heap memory, and then there is native memory. And one of the primary region in this native memory is called as a metaspace. It is a small region. This is where the metadata definitions that are required to execute your program are stored. That is, say, any class definition. See, as a developer, I write code, right? I write a customer class, account class, those kind of classes I write. Where are those classes stored? Those class definitions stored? They are stored in this metaspace. And if your metaspace gets saturated, then you are going to see this pattern. That is because when a full GC runs, it runs on all the regions to clear. And here the metaspace is getting filled up. Even it's a small region, it's getting filled up. So it runs when the memory is even at the bottom. Is it making sense? Because your memory is such a big thing, everything. But metaspace is just a small region. But just because metaspace is getting run, there's a leak in metaspace, the GCs is starting to run. So that's why it tells me when there's a memory is at the bottom itself, that's why it's running when it's at the bottom itself, right? But you don't have to worry about all these patterns. So let's say this is a live example. Let's look into this. When I open here, it tells there's a metaspace memory leak is happening. We report that. Sorry, I'm looking at I think I hyperlinked a wrong report. But anyway, if you look at it, it will tell there's a metaspace memory leak is happening. Okay. So now, when this, let me show you a demo how to simulate this metaspace problem. Right? Let's look into that. Okay, friends, look at this. This is a sample program. Out of memory error metaspace. Look what I'm doing here. Here also, once again, I'm going on an infinite while loop. And here I'm saying class name, com buggy app metaspace object. I'm appending a random number here. And then here I'm saying make a class. So what I'm doing is I'm creating a new class definition. I'm creating a new class for every iteration. I'm creating a new class. Where are the class definitions stored? Where are the classes stored? They are stored in the metaspace. So if I keep on creating these kind of classes and not relinquishing it, then my metaspace is going to get loaded. When metaspace gets loaded, then you're going to get this out of memory error. Let me run this program. You're going to get this out of memory error metaspace. Let me run it. See, here what I'm doing, after every 5,000 classes loaded, I'm just printing a statement here saying these many classes loaded, these many classes loaded. It is now growing. After a point when metaspace is saturated, see, you get this error, out of memory error, metaspace. So when all we get, okay, so if here in the code, I'm creating a lot of new class definitions, I'm going to get. But sometimes, my friends, when you keep on adding a lot of third-party jars, third-party frameworks, you keep on adding it to your application class path, those all is going to create class definitions. Then you're going to get this type of error. And sometimes I've seen, if you use the scripting languages like a Groovy, right? The Groovy, they create a lot of new class definitions for every request. Then also it's going to build up. Your metaspace is going to saturate it, right? When this kind of a problem happens, how do we troubleshoot it? How do I know what is the leaking, what is it saturating the metaspace? To do that, friends, pass this argument to your JVM. If you see this out of memory error metaspace or this kind of a pattern, then pass this argument to your JVM. If you're running in Java 8 or before, say minus verbose class. If you're running on Java 9 and above, say class loading information, give the file name. So what these arguments will do is this will print any object that is loaded into the metaspace, it's going to print it. It's going to print it, saying this class is loaded, this class is loaded, it's going to print. So once you know what are the classes that is getting loaded, because the class is going to tell you the package names where it is there. So then you'll know from where this is getting loaded, then you can arrest it. So now what I will do, let me run the same program. Let me run the same program with this verbose option. See, now I'm going to run the same program. To this program, I'm passing this verbose class option. So now let me run it. When I run, look what's going on. It is printing, oh, loaded this object, buggy up metaspace, UUID. So now based on this package name, okay, I know what is this class which is leaking. And then I can go ahead and address it, right? Okay. Okay, friends, so here is a quick recap of this pattern. When this pattern happens, you're going to get out of memory error metaspace. This happens when you are loading lot of dynamic classes, or you're loading a lot of third-party libraries into your application. So what is the solution? Fix the memory leak code, which is causing this. Or if it's for, let's say, legitimately you're adding third-party libraries, so then you need sufficient metaspace. Then increase this metaspace size to that. What is the artifact you need to troubleshoot? Use this. What are the argument I showed earlier? Right? So, friends, with this, I'm coming to the end of my talk. Thank you everyone for attending this month's monthly webinar. If you want to understand more deeper into the JVM troubleshooting and JVM performance engineering, I've given the master class, JVM performance master class in this Ycrash Academy. You can go to the Ycrash website and there is this academy you can click and then you can enroll. It's an online class. So I'm an instructor. It is a 9 hours recorded session. So you can listen to it. If you have any questions, you can ask in the forum. I'll respond to it. It may be helpful to you. Okay.